All right, picking up on problem 22, we have the function f is increasing by, or the function f is given by this equation, x to the fourth plus x squared minus 2. On which of the following intervals is f increasing? Okay, so remember, to determine like whether a function is increasing or decreasing, you want to look at the first derivative. So we have f prime of x will be 4x cubed plus 2x. And then we want to see what the sign is. If it's positive, it's increasing. If it's negative, it's decreasing. So we look first for the zeros. We try to find where the derivative is equal to 0. And then we look at what's going on after and before that 0. So we have then 0 equal to 2x times 2x squared plus 1. So we only have to, looks like, yeah, we only have to solve for where, or look where x equals 0. So we look to see what's happening before and after. So we just pick a value to the left, let's say -1, and a value to the right, +1, and we look at what f prime of -1 is. That would be -4 minus 2, and we just care about the sign. So we know it's negative. Now let's look at +1. That would be 4 plus 2, which is positive. Positive from here to there. So it's increasing from 0 to infinity. The answer is C. All right, 23, we have the graph of f shown here. Which of the following could be the graph of the derivative of f? Okay, so looking at the derivative, we want to see the sign mainly. So it looks like it's going to be 0 around this point. And then positive on this interval, and then negative afterwards. So we want to look at the graph that best matches this. I like to look first at the 0. So the 0 is going to occur somewhere around here. So then we can eliminate B. I mean, B is really the only quick elimination. Then we look where the derivative graph is positive before this point. So then it's not going to be, oh, we could always, oh, we can eliminate D from there. Because again, it goes positive to negative. A still holds because again, positive, negative on after that point. This C would not hold because it's negative, positive. And then E, this could still potentially hold. However, we want to look at the behavior. E says that it's positive, but it's decreasing, like it's decreasing at a constant rate. It's decreasing at a constant rate. But you can see the graph is positive, but it's kind of 0 here, then it's more steep, then it's getting less steep. So it's changing its like behavior. So if you look at A matches that the most because you see it's 0, like it's flattening out here, which is over here. Then it's increasing, decreasing. And so that A would be the best answer. All right, 24. We have the maximum acceleration obtained on the interval from 0 to 3 by the particle whose velocity is given by v of t equals t cubed minus 3t squared plus 12t plus 4 is. Okay, so let's work this out on a separate sheet of paper. That way I'm not cramming all the work there. And what we want to do is study the derivative of velocity. which is acceleration. So let's look at a of t, which is v prime of t. 3t squared minus 6t plus 12. And we want to see, we want to study the zeros, and we want to study the endpoints. So we can evaluate the zeros and endpoints. So then let's set this equal to 0. Factoring out a 3. We would get 3 times t squared minus 2t plus 4, which is factored further into 3 times t minus 4 times t plus 2. So zeros could potentially, we want to study what's going on at 4 and negative 2. So negative 2, 4. We also want to study the endpoints at 0 and 3. Or 0 will be over here, 0 and then 3. So one, like you could probably just plug these 4 in. It's probably going to be just as much work as studying between them. Yeah, so then plugging the endpoints in. Oh wait, we only have to plug in these. Yeah, it's 0 to, yeah, we don't even need the negative 2 actually. We only need to go from 0 to 3. So let's study 0, 4, and 3. So let's see what's going on at a of 0 and a of, wait, did I also, I put this in the wrong order? That 4 doesn't even count. That 4, yeah, let's say there's even more work. We just study a of 0 and a of 3. Okay, yeah, that makes sense. I don't like it when it's such a tedious problem, but yeah, let's just plug in 0 and 3 because 4 is not even in that interval. Okay, so that makes our lives easier. So plug in 0 into here, we would just get 12. Plug in 3 into there, we would get 3 times 9 minus 18 plus 12. So 27 minus 18, 9 plus 12, get 21. So then the maximum velocity would be 21. Or I'm sorry, the maximum acceleration would be 21. All right, 25. What is the area of the region between the graphs of y equals x squared and y equals negative x from 0 to 2? Okay, so this is, we just got to integrate. Integrating, setting up our y equals x squared and y equals negative x. From 0 to 2, let's make this line x equals 2. So we're just trying to find essentially this area. So this is going to be equal to the integral from 0 to 2, the top function, x squared, minus the bottom function, which is negative x. Integrating this, this just becomes the integral x squared plus x dx. Working this out, we'll get x cubed over 3 plus x squared over 2 from 0 to 2. Plug in 2 in, we'll get 8 over 3 plus 4 over 2 minus 0 because that 0 doesn't do anything. So 8/3 minus, which is just 6/3, or 8/3 plus 6/3. So 14/3. And so the answer is D. 26. Function f is continuous on the closed interval 0 to 2 and has the values given in this table above. The equation f of x equals 1/2 must have at least 2 solutions in the interval 0 to 2 if k equals. Okay, so the best, or what I recommend, is to draw a visual. we know that at 0, we have f of x is 1, so we have the point 0, 1, and we have the point 2, 2. Two, 1. We want to figure out what's going on at 1. Now, if we have the equation f of x equals 1/2, that's just a horizontal line looking something like this. And if it says it's continuous on this interval, so for it to have at least 2 solutions, it has to cross this line at least twice. So like it has to go below it. Has to go below it, at some point. So we have to have that the k value has to be less than 1/2. It doesn't have to be 0 necessarily. It doesn't have to be -10. It doesn't have to be 1/4. This has to be less than 1/2. But the possible answers that it only gives that are less than 1/2 are 0. So then the answer is 0. Because that just means it may look something like this. Or that just means it gets the x-axis. And last two, what's the average value of y? Equals x squared times the square root of x cubed plus 1 on the interval 0 to 2. So this is one that we're just going to use U substitution. So remember, average value, we use the 1 over b minus a times the integral of the function. So in this case, we just integrate this 1 over 2 from 0 to 2 of x squared times x cubed plus 1 dx. Using U substitution, we're going to make u equal to x cubed plus 1. Then du will be 3x squared dx. Solving for x squared, we would just have 1/3 du equal to x squared dx. So then we can rewrite this as 1/2 times integral of 1/3 square root of u du. And make sure that the endpoints, you put them back correctly, because now they're in terms of u. So we plug 0 into x for the lower endpoint, and then we would get 1 for u. Plug 2 in for x, we would get then u is 9. So we can integrate then from 1 to 9. Integrating this, we would get 1, and we could factor out that 1/6 times u to the 3/2 over 3/2 from 1 to 9, which is the same as 1/6 times 2/3 u to the 3/2 from 1 to 9. Working this out, we would get 2/3 9 to the 3/2. 9 to the 3/2 will just be 9 times the square root of 9, or 9 times 3, minus 2/3 times 1 to the 3/2, which is just 1. And so then we get 1/6 times 18 minus 2/3. 18 thirds, or 18 times 3 is 54. 54 thirds minus 2/3, you get 1/6 times 52 thirds, which is just 52 over 18. Reducing this, we would get 26 over 9. And I believe that's as far as we can go. Yeah, and the answer is A. All right, last one. 28, we got if f of x is the tangent of 2x, then f prime of pi over 6 is, all right, so then we just have to find the derivative of this. So using chain rule, we would take the derivative of 2x, which is 2, times the derivative of the tangent function, which is the secant squared function. So it's 2 secant squared of 2x. Evaluating this at pi over 6. 2 times the secant squared of 2 pi over 6, which is just 1/3 pi. This is just 2 times secant of pi over 3. Remember, the cosine of pi over 3 is 1/2. So the secant of pi over 3 is 2 over 1, or just 2. So 2 times 2 times 2. So 4 times 2 is 8. And so the answer is E. All right, so we're done with the first multiple choice section. So any questions, any comments, feel free to let me know. Feedback is always welcome. If this helped you, please give me a like and make sure to subscribe. I'll see you guys in the next video.